Hi, today we're going to be talking about quadratic functions and how to graph a quadratic function. Okay, right up here, here's the general form of a quadratic equation, y equals ax squared plus bx plus c. And notice that the general form has three parts, an a, b, and a c. Okay, but the thing that makes it a quadratic is the second power here. So anytime we have an x squared term as the largest power, the degree of the polynomial is called a quadratic. Okay, we'll look at the graphs of these here in a minute, but we're going to start with this one called the parent function. What the parent function is kind of the generic plain Jane graph of a quadratic equation. Okay, and let's see, I'm going to grab my calculator and let's graph y equals x squared. So I'm going to go to y equals and do x squared. I'm going to take a look at its graph. You can see right there it's this U-shaped thing. Okay, and I'm going to just make a little sketch of one right over here. And it looks something like this. Okay, there's a special name for that thing. It's called a parabola. Okay, and I'm going to write that right over here. Okay, these things are called parabolas. They're U-shapes. Okay, notice down here at the bottom, it's a curve down at the bottom. It's not a V, but a rounded part down there at the bottom. Okay, speaking of that bottom part, it has a special name. It's called the vertex. Okay, and the vertex, in this particular one, the parent function goes through the origin 0, 0. Okay? Another thing about parabolas here is that they have this thing called a line of symmetry. They're symmetrical. Okay? If you remember what symmetrical means, it means if you divide it in half and flip it over to the other side, it matches up perfectly. Okay? And like I said, this is what's called the axis of symmetry. The line that cuts it in half goes through the middle of it. They're going to ask us to find the equation for that axis of symmetry today. Okay? And the axis of symmetry is always going to be a vertical line that goes through the vertex. And if you remember, the equation of a vertical line is always x equals something. So when they ask us for that equation, we're going to find out, well, what x value does it go through? Well, in this particular case, it goes through the origin. The x-coordinate of the origin is x equals 0. Okay, so that's another thing with these parabolas. Okay, another thing here is they're going to talk about the domain and the range of a parabola. Okay, from the past, you guys know that the domain talks about the x values, and the x values go left and right horizontally on a graph. Well, let's look at the x values of a parabola. This graph, it goes to the right forever. It's going up, but it's getting wider, so it's going to the right. It's going up and to the left forever, so right forever, left forever, everything in between. X can be all real numbers. It can be anything. It turns out that all parabolas have a domain of all real numbers. Okay? Well, if the domain is the x values, the range are the y values. What possible y values can there be? Okay, well, y values talk about how high or low the graph goes. And you can tell from this one obviously goes up forever, but it doesn't go down forever. No, it stops right down. In this particular one, it stops down here at 0. So all the y values are from 0 and above. And the way I say that is y is greater than or equal to 0. Okay? So there's kind of the major parts of the parent function. Okay? Just taking a step further here, do parabolas always open up like that? Not necessarily. Okay? The letter A out here in front of the x squared is going to tell us if a parabola opens up or down. If A is positive, it's going to open up. Okay? And if A is negative, it's going to open down. Okay? So just out of curiosity's sake, what if this was a negative x squared? How does that change my graph? Okay? The parent function would look something like this. Okay? Does it still have an axis of symmetry? Yep, it'd still be at x equals 0. How about domain and range? Oh, by the way, is the vertex still at 0, 0? Yes. How about the domain and the range? Okay, the domain, it still goes to the right forever. It still goes to the left forever. So the domain is still going to be all real numbers. But the range on this one, though, the range is going to be a little bit different. Instead of it going up forever, it looks like this one goes down forever, and the highest it goes right here is 0. So all the y values are going to be from 0 and below. So the y values are less than or equal to 0 on a parabola that opens down. Okay? We'll talk more about that here in just a minute. Okay, but those are the major main parts of a quadratic function. Okay? Before we go on to the next thing here, I just want to mention one other thing. One other thing here. Okay, if I have a parabola that opens up like this. Okay. Now I know that that point right down there has a special name. It's called the vertex. Okay? But also on a parabola, that's the lowest point of a parabola that opens upwards. And there's a special name for the lowest point on a graph that starts with the letter M. It's called the minimum. Okay? And if I have a parabola that opens upside down and goes this way, okay, this right here is the highest point of that parabola, and it also has a special name. It's called the maximum. Okay? So identifying that vertex, or in other words, the minimum or maximum, is a very, very important part of that parabola, and that's what we're going to do here in just a second. Okay? Knowing what that minimum and maximum point are, the highest point and the lowest point. Okay, but again, if it opens up, we'll go write this here. If it opens up, it's going to have a minimum. And if it opens down, it's going to have a maximum. Two really, really, really important words. And that maximum and minimum point are going to occur at the vertex. Okay? All right. Let's take a look at the graph here. Or actually, before we get to that, a couple other things. Here's the general form of a quadratic equation. Again, and this page is in your book. Just wanted to show you this just in case you wanted to go back and take a look at it. Kind of defines the different parts that we did a minute ago. And this page is also in your book where it talks about the minimum and maximum values. Okay? And if you look kind of right here, and right here, if it opens up, it has a minimum. And that's when A is greater than 0. In other words, when A is positive. And it opens down and has a maximum. And that's when A is negative. Okay, but this is another good reference point or reference tool if you needed to or wanted to go back and look in your book. Okay, to talk about maximums and minimums. All right, so here's the next thing that we're going to do. And this is, you're going to be doing a bit of this on your homework assignment today. About graphing some functions and finding those 7 things. Now, it looks a little overwhelming right now, like a great big list of things you have to find. But you'll see here, it actually goes pretty slick, pretty fast. Okay, we're going to start by doing this one right up here. Okay? And eventually what I'm going to want to do is we're going to want to make a little graph. Okay? Now, in the resources here in the Google Classroom, I did attach some graph paper to that. Personally, I think it's going to be easier to graph on graph paper as compared to making a freehand sketch. If you wanted to print that off, if you wanted to find your own graph paper somewhere, I think it's a little bit easier because it has the squares that you can count. But if you're going to make one by hand, just make sure you make it nice and neat. Don't make it so teeny, teeny, tiny that I can't count the squares and you can't count the squares. Make sure your tick marks are evenly spaced and things like that. But just be neat with them so that we can see them. Okay? All right, so this is eventually what we're going to do is we're going to want to graph these. Okay? And we're going to start out by finding the vertex. In other words, we're going to find its maximum or minimum. Well, if I look carefully at this equation here and I look at A is a -2. Okay, that should tell us whether it opens up or down and whether or not it has a maximum or a minimum. And because A is negative, like we saw a minute ago, that means it opens down, and it's going to have, and if it opens down, it's going to have a maximum. So to start with here, we're going to try to find the maximum or the high point of that parabola. Okay, I'm going to go back to our calculator here. I'm going to go type that equation in. It's -2x squared plus 8x minus 3. Okay? If I type that in, if I press graph, look at that, it sure does. It does indeed open down, and it has a maximum right up here. Okay? Now, we need to find that point. Okay? To find that point, we're going to have the calculator find us that point. Let's let the calculator do the work for us. Well, where in the world on the calculator can it find the maximum? Okay, here's the thing. If you press second trace and then trace gets you to this screen, And look at number 3 and 4. There's our maximum and minimum buttons. Okay, since we want a maximum here, I'm going to select number 4 and press enter. And when I get back to the screen here, down at the bottom it says left bound. Okay, what this means is we're going to take our cursor and we're going to try to put it on the left-hand side of the vertex. Just up over the hump on the left-hand side, I'm going to press enter. Okay, then when I press enter, it's asking me for a right bound. That means I'm going to go up and over the hump to the right side of the vertex. Just a couple clicks and press enter. And then it asks me for a guess. Okay, well I can move the cursor as close as I can or where I think that vertex is, and I press enter one more time. And if you look down there at the bottom, there it tells me the vertex of my graph. And it looks like the vertex is at 2, 5. Okay? These 7 things, by the way, I'm going to have you do all 7 of them on the handful of problems that you have to graph today. Okay? So there's the first point. Okay? Now, oops, and I'm going to put it up here, over 2, up 5. 1, 2, 3, 4, 5, right up here. Okay, so I need to make a nice big point on my graph. Next, I need to find other points. It's not okay just to, once you get a vertex, and draw a U, draw a parabola. No, we need more points than that. People always ask me, well, how many points do you need? Well, I think it's always best to have at least a couple on this side of the vertex and a couple on that side of the vertex. Okay, well, where do those points come from? Well, if you look at number 2 here, we're going to use the table on your calculator to find those other points. And I think you've done this before. If I press second graph, I get to my table. Okay? And most of the time the graph paper only goes up to 10 or negative 10. So we're going to mainly focus on the y values that are between negative 10 and positive 10. Okay, oops. Okay, and it mainly is looking like 1, 2, 3, 4, 5 points. Okay? You don't have to write the table down if you don't want to. We can just copy them right off the calculator. So the point 0, negative 3 is on here. Over 0, down 3. Over 1, up 3. 2, 5 is already on my graph. Over 3, up 3. And over 4, down 3. Okay, and you can see it makes a nice little parabola. You can see those points nice and clear. When you guys mark these on your homework, make sure you make those points nice and big so I can see them. And then we connect them with a nice little curve. And take your time and be neat. Don't be in a hurry. And once again, up here at the top, notice it's not a V, it's a rounded curve. Okay? And a lot of times when you do these on your calculator and you find these points, a lot of times they're going to have matching points right across from each other. Not always. I'd say most of the time they have matching ones right across. Okay? And there's our graph. Okay? Number 3 here, can we find the axis of symmetry? Well, the axis of symmetry, remember, is the line that goes right through the middle, just like this. Okay? And if you remember the equation for the line of axis, or the axis of symmetry, it was always an x equals something. And what x value does it go through? It goes through 2. X equals 2. And you'll see as we do some of these, there's a big relationship between that number and that number right there. Okay? The axis of symmetry is always going to be the x-coordinate of the vertex. Okay? How about number 4, the y-intercept? The y-intercept, if you remember, is the point where the line crosses the y-axis. It's right down here. When I look at the graph on the calculator, though, it's sometimes hard to tell. It's down here somewhere. Okay? But there's one thing kind of unique about the y-intercept. The coordinates of the y-intercept, the x-coordinate of the y-intercept, is always 0. It's always over 0 and then up or down something. Well, how can I find out what exactly that point is when x is 0? If you go back to your table, I'm going to go second graph again to my table and find out when x is 0. And I can see right there that its y value is negative 3. So 0, negative 3 is its y-intercept. Okay? So again, the calculator is doing a lot of the work for us here. Okay? Number 5 is graph the equation. Well, we already did it. Okay? And then last but not least, it wants that domain and range again. And if you remember, the domain is the x values, and the range, is the y values. Yep. Okay? The x values, again, is always all real numbers. Okay? It goes to the left forever and the right forever. Okay, and everything in between. The y values, though, okay, up here, this is the highest the graph goes. And the highest it goes is 5. Okay? Kind of a unique relationship between that number and that number. And the graph of this parabola, all the y values are everything below 5. And the way I write that, y is less than or equal to 5. Okay? And there we have it. Okay, there's the graph of our parabola. We labeled all the important parts, described its domain and range, and there we go. Okay? All right, let's see if we can try another one here. Let's see if we can try this one on the right. Okay, one more time here. Now that we've got one of them under our belt here, let's try and tackle this guy right here. Okay, so before I graph it, if I look carefully at that equation, can we decide if it opens up or down? Well, I'm going to look at A here. It's a positive 4. And when that number in front of the x squared is positive, that means it's going to open up. And if it opens up, it's going to have a minimum, a small point, a lowest point. So this time, to find the vertex, we're going to be looking for a minimum. Well, like we did before, let's use the calculator to find that minimum for us. I'm going to go back to y equals. Let's type in this new equation, 4x squared minus 8x plus 1. I'm going to hit a graph of it. Okay? Well, look at that. It sure does look like it has a negative. Okay? And can we find that point? Can we find exactly what that point is? Okay? If I press second trace again, and this time I want to choose number 3, my minimum, and again it's asking me for a left bound. Well, remember, right down here is our vertex. Now on one that opens up like this, the left bound is going to be on the right side. So I'm going to get my cursor, I usually go within a click or two, down there in the left bound, press enter. The right bound, I want to click over to the other side a click or two. And the right bound is going to be on this side, obviously. And I'm going to press enter. Then I go down to guess, down here at the bottom, as close as I can. I press enter again. And it tells me my minimum is 1, negative 3. 1, negative 3. And that's my vertex for the graph. And if I was doing this on my homework, I'd grab my graph paper, or I'd make a little sketch here. And I like putting that point in right away. Over 1, down 3, right about there. Okay? And when I ask myself, does my graph paper, does it match my calculator? Does it look like the vertex is at right 1, down 3? It sure does. Okay? Now to get my other points, okay, as it says there, number 2, we go to the table. I'm going to go second graph, go to my table. And again, this time I only have, it looks like a couple points that are between 0 and, I'm sorry, negative 10 and positive 10. There's my 0, or 0, 1 I should say. Over 0, up 1. 1, negative 3 I have. Over 2, up 1. Okay, and then the numbers get to be big. Over 3, up 13. I could go over 3 and go up 13 up here somewhere. And I could go left 1, up 13 up there somewhere. And there's nothing wrong with doing that. Okay? But for sure, I have these right down here that I'm going to connect with the curve. And if you want to go all the way up to there, you can. Otherwise, we would stop right there. Okay? But maybe I'll extend it. Okay, but there's that parabola. Okay? The axis of symmetry. So we've done this, we've done this. How about our axis of symmetry? It's a line that goes through the middle. And remember, it goes through the vertex. And what x value is the vertex at? X equals 1. There's my axis of symmetry. X equals 1. Okay. My y-intercept. I'm going back to the table, and remember the y-intercept is the value of y when x is 0. In looking at my table right there, when x is 0, it's right on there. The y value is 1. So 0, 1 is my y-intercept. And it looks like it crosses the y-axis at 1 right there. So looks right. Yeah. Okay, graphing we already did. We did this, we did this. How about domain and range? Well, we've talked about this a couple of times now. The domain is always x equals all real numbers. Okay, it's going left and right forever, everything in between. And the range then is the y values. Okay, the y value, okay, the lowest y value right down here is negative 3. That's the lowest it goes. And everything else is above it. So all the y values are greater than or equal to negative 3. And there we have our parabola. Okay, so it looks like a lot of stuff, but it's not too terribly bad. Okay, so like I said, there's going to be a handful of problems that have you do all of this stuff. and make the actual graph. Okay? All right. And by the way, on your homework assignment, I think I mentioned in the directions, I changed the directions to make sure that you add all 7 of those things. And it says that in the notes in the classroom, okay, by the assignment. Okay? Other problems, these are our last 2 here. Our other problems are just going to have you, they're not actually going to have you make the graph, they're just going to ask you a couple questions about it. Determine if this one has a maximum or minimum value. Okay? Well, again, if I look at the very first number, the A out here, the 4, okay, is it positive or negative? Well, it's a positive 4. A positive 4 means the parabola is going to open up, and that means it's going to have a minimum value. Okay? It then wants us to find that minimum or maximum value. Well, basically what we're doing is we're finding the vertex. Let's let the calculator do it for us. Okay? If I go back to y equals, I'm going to type that equation, 4x squared minus 24x plus 11. I'm going to graph it. Okay? Ooh. Look at this. One thing about this one, I can't really see the vertex. Okay, it's opening up, but it's down here somewhere. Before we can do the maximum or minimum thing with our calculator, we need to see the vertex. And sometimes in order to do this, we have to adjust our window. I'm going to press my, and by the way, I need to see down further, down lower. So when I press my window button, the one that allows me to see down lower is the y minimum. And right now it's going down to negative 10. It looked like I had to go down there quite a ways more, so I'm going to maybe make that become negative 30. Okay, and then I'm going to press graph again, and hey, that's far enough. Yep. Now I can do second trace, choose number 3, my minimum, and I got to do my left bound. Here it comes down there. I get down on the left side a click or 2 and press enter. My right bound, I'm going to click it over to the other side a click or 2 and press enter. And my guess, I'm going to go close and press enter. And there's my vertex right there at 3, negative 25. Okay. Now, I'm going to push pause here for a second. In looking at that minimum, that vertex down there, which number actually technically is describing the minimum value of the function? Okay. The actual minimum is negative 25. Okay, that's the lowest it goes. Okay, this will come more into play later this chapter. But the 3 is telling me how far over we went before it hit that minimum. Okay? But to be on the safe side, you can write the x-coordinate and the y-coordinate. I'd write them both to start with. Let's find that actual vertex. And then state the domain and the range. Okay? I'm just going to abbreviate here, domain and range. The domain is always x equals all real numbers. And how about the range? If we look at the graph here, this is the lowest point, and it's down there at negative 25. And the rest of the graph is everything above negative 25. So all the y values are greater than or equal to negative 25. Okay? So there are going to be some problems like this that just ask you to find the different parts, the max, the min, the domain, and the range. Okay? Don't have to do any graphing. So those are a little bit nicer, and let the calculator do all the work for you. Okay? I have one left for you here, I think. Oops, yes, this one right here. Determine whether it has a max or minimum value again. Well, I'm going to look at the leading coefficient out here on the x squared term, the a. This time it's negative again. A negative a means it opens down, which means it's going to have a maximum. So this time it has a maximum. For part B, let's find that maximum. Okay, now I'm going to go back to my calculator here. I'm going to go to y equals, press clear. I'm going to type in negative 3x squared plus 6x plus 4. I'm going to hit graph. Now, one thing here, this is a little thing, but notice my window. It's still set from the last problem. And we've done this before, but how do I get it back to the normal 10 by 10 screen? I'm going to press zoom and number 6. It'll reset that window automatically. Sometimes maybe it makes the picture look a little bit nicer. Okay, and we can see, yep, it has a maximum. Let's find that maximum. So we go to second trace, maximum. My left bound is going to be on the left-hand side of the hump. My right bound, I'm going to come up and over to the right-hand side a click or 2. And my guess, I'm going to go back to the middle. And this time, there's my maximum value right there. Now let's talk about that for a second. Look at that. 0.999999999. What's that pretty darn close to? It's pretty darn close to 1. Okay? And when we get all 9s like that, we're going to round it up to 1. Okay, I know some of your calculators actually give you 1/7. I don't know why some do and some don't. Okay? But yeah, when it gives you all 9s, we can round up. Some people's might say 1.000000006 or something like that. If it has all these zeros, we're going to assume it's 1. Okay, and why some calculators do that, I'm not exactly sure. Okay? But there's our maximum. Okay? And then our domain and range. The domain is x equals all real numbers. And what about the range? Again, the highest this graph goes was 7. Okay? The y coordinate, the highest that went was 7. And as you look here at the graph, the graph exists everywhere below 7. So all the y values are less than or equal to 7. Okay? So there we have it. That's kind of what we're looking at today. Just identifying the different parts of the graph, making a graph, and take a look at its max and mins. Okay? All right, thanks for tuning in.